Okay. So very important topic, and not only for the exam, but whenever you are going to do any performance analysis of the system, at that time the steady state error estimation becomes a very important topic. So for any system, how does it perform? And every system, it is said theoretically that whenever it is performing and producing some kind of output, like the control system or any other system, it does not give us 100% satisfaction. So there is certain amount of error that we find at the output of the system. So that error actually is called as a steady state error, because we found that in any system response there are two states. Initially, when time is very less, at the time it is called as transient response. In that transient response, the waveform starts building up, and after a certain time the waveform reaches to the peak or maximum. So whenever it is reaching peak, so that time is called a settling time, and after settling time Ts, the waveform is called as a it has entered in the steady state. So when the waveform enters in the steady state, its amplitude variation is very minimum, almost zero. That means amplitude has got steady to a certain value. So if I'm giving an input voltage of 1 volt unit step, and if the system capacitor voltage output is also 1 volt, in that case we call that difference between input and output is zero. So in that case, steady state error is equal to zero. But if the same input I give to a RLC system or maybe RC system, and across the capacitor we are getting zero point 0.8 volt. So input is 1 volt and output is zero point 0.8 volt. Okay, so at that time we are finding that the difference between input and output is 1 minus zero point 0.8, that is 0.2 volt. So in that case we can call that at steady state, that means after the waveform has reached the steady state, input and output difference is 0.2, so that will be called as a steady state error. Okay, so this error analysis is a very important thing, and you are finding that in your syllabus. The steady state error analysis is almost in the middle of the chapter. So after we have studied how to generate the different types of responses, so ramp response we have not done, but yes, impulse response and step response for RL, RC, RLC we have seen. And after we are getting the response, then we have to decide whether the response is up to the mark or the response is having some kind of error in that. So let us start with, so I will remove this slide, and I will project some other thing, that is we are entering the very important part of system error analysis. And there are a lot of documents that I have, but one of the document is their concept and type of error, and there is a concept of type, concept of uh, closed loop system, open loop system, and all those things. So let us start building all those things step by step. So first I would like to give you or tell you four concepts, so you can write it down. The first concept is called as a type of the system, and the second concept is called as the type and what is the order of the system. Okay, so let us see that, and after that we will be saying okay, so let us start with this block diagram. Is this visible, this diagram, my handwritten notes, is it visible?
Yes, sir.
Okay. So let us have this understanding first, that is what is meant by system error and how to find out the system error. So is this block diagram known to you, or should I have to explain this?
Known, sir.
So RS is the input, ES is the error, ES is equal to RS minus BS. BS is equal to HS into CS. So this proof also you have done, but this proof you have done for G divided by 1 plus GH. So when I had given you the closed loop transfer function at that time, what was the closed loop transfer function? For that you had did this proof, but here we are going to find out the equation of ES. Okay, so this error, what is the equation of that? To find that, we are going to do a proof, same proof, but there is a little twist in the end. So let us start with this. ES is equal to RS minus BS. So error is equal to input minus feedback. Okay, and generally we are considering negative feedback. So whatever input we are giving, that input minus feedback, that is actually is equal to the error signal. Now some book they are saying BS minus RS, but standard way if you are saying it is actually RS minus BS. So input is equal to error is equal to input minus feedback. and Bs is equal to Hs into Cs. So here you are finding this output is coming, and that is multiplied with Hs. So this Bs is equal to Cs into Hs. So what Es is equal to Rs minus Bs, and Bs is equal to Hs minus Cs. So Es is equal to Rs minus Hs into Cs. I don't think there is any doubt in the first line, because Cs, that is output, is equal to Es into Gs. So again we know that whatever output is there, that is input multiplied by the forward path gain. So Gs is the forward path gain and Hs is the feedback gain. So Cs is equal to Es into Gs. So again come back to the same equation, that is Es is equal to Rs minus Bs, or Es is equal to Rs minus HSCS. In that Cs, so from here, from the top equation, substitute Cs is equal to Es into Gs. So what you are finding is equal to Es is equal to Rs minus Hs into Es into Gs. Then what you do is, this second term, this negative term, you take in the left and take Es common. So for what you are getting is, so this second term in the right hand side, you have to take it in the left hand side and take Es common. So if you are taking Es common, this becomes 1 plus GSHS, and right side it is Rs. So one very important equation it is generating, there is an error signal in Laplace domain, that is Es is equal to Rs divided by 1 plus GSHS. And if I ask you what all these things are, so Es is equal to error signal, that is Rs minus Cs, Rs minus Bs, that is equal to Rs. What is Rs? Rs is the command input or set point input, divided by 1 plus Gs is the forward path gain, Hs is the feedback gain. So just in the yesterday's lecture only, we have seen it is a step response. Okay, so step response means ut, and what is the Laplace transform of that? 1 by s. Okay, so if we I'm giving for a certain forward path gain Gs, for a certain feedback gain Hs, if I inputting unit step response and I'm asking you that estimate what is the error. Okay, I'm giving the step input, so let be RC circuit. Okay, let be RC circuit, and in that I'm inputting step input. I'm asking you how much is the error. Okay, so you have to find actually error in time domain, so you have to find Et, but here what you are actually finding is Es. So Es is equal to Rs. So if I'm giving unit step input, Rs will be 1 by s, 1 plus Gs and Hs. So Gs and Hs will be given to you. If it is said that unity feedback system, in that case H is equal to 1. And why this is 1 plus? Because this is negative feedback system. So if I mention what is the type of the input, that comes at the numerator, Laplace of that, unity feedback system, or maybe feedback system with gain of 0 0.2, 0 0.3, 0 0.4, so Hs is that value, and forward path gain Gs should be given to you. And one very important thing, Gs into Hs, what is that thing called? Gs into Hs is called as a open loop transfer function. So this is also a very important thing you remember. So error Es is equal to called as input divided by 1 plus Oltf. So this is a formula you have to remember, that is error in Laplace domain is equal to input, that is Rs divided by 1 plus Oltf. Oltf full form is open loop transfer function, that is nothing but multiplication of forward path gain into feedback gain. So is this formula okay? Es is equal to input by 1 plus Oltf.
Yes, sir.
No doubt, right? Is
No,
there any
sir.
doubt in this? No doubt. So can you find Et? Can you find the Laplace transform of this if I give you the values of Rs, Gs and Hs? Only you have to just take the inverse Laplace transform and you can find what is Et. So error at any time. Error at any time you can find. So Es, this error is in the Laplace domain, that is Rs divided by 1 plus GSHS. You have to take inverse Laplace, that is Et. You will be finding an equation in time domain like we have seen previously. So that is 1 plus e raised to minus t by tau, maybe plus 2 into e raised to minus 4 t by tau or something. Okay, and there different values of t you have to substitute. So if you are substituting t very small values, 0, 1, 2, 3, in that case you are finding error in the transient region. And if you are substituting t is equal to infinity, so what is the steady state error? Steady state error, yes, okay, but there it is not time domain. So if you are taking et, how can you find Et from Es? Es is in Laplace domain, Et is in time domain, so you have to take inverse Laplace transform of Es. Then you are getting Et. That Et at t tends to infinity. So this you have to remember, that is Et, whenever error is there, that is at very high value of t, and highest value of t can be t is equal to infinity. So Es formula I have given you, because all the calculations we do in the Laplace domain. From there we have to go back to the time domain, that is Et. You are getting an equation, and in that Et you have to substitute t tends to infinity. Then whatever value of error you are getting, that is called as a steady state error. Okay, so example is given below. There is an example for a feedback system, gs equal to 1 by s plus 2, and feedback gain is equal to 2. Okay, so I'm just giving a feedback gain is equal to 2. Generally we highest value of feedback gain we take as 1. So what is the error in that case? So this is rs divided by 1 plus gshs. So it is error is equal to rs. Okay, so what is the input to the system? Input to the system has to be mentioned, unit step input. Okay, so whenever I'm saying unit step input, in that case it will be something else. So if I'm giving you this, cs by rs becomes gs by 1 plus gshs. So what is cs by rs? This is called as closed loop transfer function. And what is gshs? This is called as an open loop transfer function. So es is equal to error is equal to rs divided by 1 plus gshs. This is a formula. And cs by rs is gs divided by 1 plus gshs, that is 1 by s plus 3. So gs is 1 by s plus 1 plus, but closed loop transfer function become 1 by s plus 3. Is it understandable, Vinay, so far whatever I'm saying?
Yes, sir.
Any doubt in this? What is open loop? What is closed loop? Then input is 1 by s. Okay. Now two ways we can find out what is the error. So find out what is es. So es is rs. Rs is 1 by s, that is input, plus divided by 1 plus 2 by s plus 1. So if you are just doing that and you have to do some kind of rationalization, so this becomes s plus 1 by s into s plus 3. If you take the inverse Laplace transform, sorry, if you take the partial fraction, this becomes 1 by 3s plus 2 by 3 into s plus 3. So from here you take 1 by 3 outside. Then es you are finding. How to find et? Okay, es you have found. Then how can you find out et is? Take 1 by 3 outside. Then what you are getting is 1 by 3 of s, that means 1 by 3 of et. That means this is a unit step response with amplitude of 1 by 3. So this is a dc with 1 by 3 and 2 by 3 e raised to minus 3t. What is the amplitude of this 2 by 3 e raised to minus 3t? Any idea? So you substitute t is equal to 0. Can you tell me what is the amplitude of this? 2 by 3 e raised to minus 3t at t is equal to 0. How much will be the amplitude? Only this part.
2 by 3.
2 by 3. And at t is equal to infinity, what is the amplitude?
0.
0. Very good. So as t increases, and what is the amplitude of 1 by 3 ut at t is equal to 0 and t is equal to infinity? 1 by 3 ut
1.
at t is equal to 0. Amplitude
1
is
by
1 by 3. At t is equal to infinity, amplitude is 1 by 3. So this is a DC. Okay, so whatever error you are finding et, this is having two parts. One is a steady part, that is DC part. Another is a reducing part. Okay, so at t is equal to 0, how much will be the error? At t is equal to 0, error will be 1 by 3 plus 2 by 3. That means 1. Is it understandable? At t is
Yes.
equal to 0, the total error will be 1 by 3 plus 2 by 3. That means error will be 1. That means at t is equal to 0, the error is maximum. Error is maximum means the difference between input and output will be maximum. What is the input to the system? What is the input to the system? लिखा है देखो. What is the input to the system?
U of t, sir.
U of t. What is its amplitude? At t is equal to
1.
0? 1. What is amplitude at t is equal to infinity?
1.
1. Okay. Now you are finding that at t is equal to 0, error is 1. What is error? Difference between input and output. So input is 1 and error is 1. How much is the output then at t is equal to 0? Input is 1, error is 1. Error is equal to input minus output. So if input is 1 and error is 1, how much is the output?
0, sir.
0. Correct. So what is this waveform increase? What is this waveform like? This waveform at t is equal to 0, amplitude is 0. Okay, and you are finding at t is equal to infinity. At t is equal to infinity, how much is the error? Can you tell me? In this equation of et, substitute t is equal to infinity. So what is this 1 by 3 ut? This will be 1 by 3. What will be 2 by 3 e raised to minus 3t? This will
It's
be
1
0.
by 3.
Error is 1 by 3. So that 1 by 3 remains. Okay, initially also it is there and finally also it is there. So how much is the steady state error? What is steady state error? Et as t tends to infinity. So how much is the steady state error at t is equal to infinity? That is 1 by 3. How much is 1 by 3? 0.33. So input is 1 and error is 0.33. How much is the output? That means Input is 1 and error is 0.33. How much is the output?
0.7.
0.67.
0.67. Yes, sir.
समझ में आया? That means this waveform starts at t is equal to 0 and it rises. Is it understandable?
Yes, sir.
Is it understandable? Because at t is equal to 0, the amplitude is 0 because error is 1. At t is equal to 0, amplitude is 0 because error is 1. That means the waveform starts from 0 and it keeps on increasing and it gets steady state. How much? Where does it get saturated? It gets saturated at amplitude 0.67. That means initially the error is 1 minus 0, that is 1, and finally the error is 1 minus 0.67, that is equal to 0.33. What is that 0.33 called? अभी समझ में आया ये 0.33 कैसे आया? In this equation of et, substitute t tends to infinity. The next part, this part is called as transient part of the error. Transient means which is depending with respect to time. And this 1 by 3 ut, this is called as a steady part of error. Okay, whatever may be the time, this steady part of the error. So this is a DC error. Whatever is the error, that is also having two parts. One is the time dependent part, one is time independent part. So first part is called as a time independent part. Anything can be the time. This 1 by 3 DC error will always be there. Error means difference between input and output. And the other part, this is actually a time dependent error. For less time, this error is high. For more time, this part is less. Okay, so finally at t tends to infinity, you are finding, so steady state error formula चाहे तो लिख के रखो et at t tends to infinity. So in this case, you are substitute t tends to infinity, you will be finding the error will remain as 1 by 3. So error is 1 by 3, that means 0.33 means output is 0.67. So this waveform starts from 0 and it gets steady up to 0.67. Actually, the diagram I have drawn is for error. Okay, what will be the output graph? Output graph will be just 1 minus of error graph, because error is error, and this is the error graph. And what is the input? Input is 1. So what is the output? So I told you that error is equal to input minus output. So output को left में लाओ, e को right में लेके जाओ. That means output is equal to 1 minus error. Why 1? Because input is unit step. Is it understandable? Error is input minus output. That means output is equal to input minus error. Is it understandable?
Yes, sir.
Okay, so this graph is understandable. Why is it so? So this graph is having two parts. One is 1 by 3, that is the steady error, and second one is 2 by 3 into e raised to minus 3t, and this is that exponential part. And at t tends to infinity, the overall error becomes 1 by 3. So error initially is very high, and the error actually with respect to time, this error keeps on reducing. So this is actually the graph of error, but generally we find the graph of output. Okay, so this is a formula, ye likh ke rakho. This is ESST. SS stands for what? SS stands for steady state. So just now what you have found, it is called as ET as at t tends to infinity. ET at t tends to infinity. ये देखो लिखा हुआ है नीचे, limit t tends to infinity ET. What is ET? ET you don't know. What you know is ES. ES is equal to, what is the formula? What is the formula for ES? अभी prove किया था. RS divided by 1 plus GSHS. Have you seen this? ES
Yes,
is
sir.
equal to RS divided by 1 plus GSHS. Have you seen this? In the previous page only we have proved it. Okay, ES is equal to RS by 1 plus GSHS. What is RS?
1 by s.
Nee, what is RS? What do you call it? Not every time RS will be 1 by S.
Oh, okay. Sir, Laplace transform of the input.
Correct. Okay, so input can be step. In that case, RS is 1 by S. Input can be ramp. In that case, RS will be, what is the Laplace of ramp? What is the ramp signal? Ramp signal is t. What is the Laplace transform of t? 1 by S square, right? So if
Yes, sir.
input is 1, Laplace is 1 by S. If input is t, that is ramp, in that case, the Laplace transform is 1 by S square. Okay, so this input can change. So don't say RS is equal to 1 by S. RS can be 2 by S. If input is 2 of unit step, then RS can be 2 by S. So RS is input. This is we know. What is ES? ES is the Laplace transform of error. What is GSHS? GS is forward gain and HS is feedback gain. What is GSHS? GS into HS, what do we call it? It is called open loop transfer function. Last day also you had this confusion. Okay, so it is very simple thing. Try to remember whatever things are being taught. GS into HS is called as a open loop transfer function. What is the formula for closed loop transfer function? CS by RS.
G of S by 1 plus G of S.
G divided by 1 plus GH. And what is GH?
Open loop transfer function.
Open loop transfer function. So can I say that closed loop transfer function is equal to forward path gain divided by 1 plus open loop transfer function? Can I
Yes,
call
sir.
it? Okay, so ये सब formulas याद रखो. So this is the basic understanding, and this formula which is given at the end, this is very much important. So system steady state error, यहाँ पे दोनों domain में output दिया हुआ है. So first we have studied this thing, limit s tends to 0, limit t tends to infinity et. This is actually the definition of steady state error. What is meant by steady state? System response at t very high, system response at t tends to infinity. Okay, and what is meant by steady state error? Whenever the system output has reached to the final value, at that time whatever is the difference between input and output, चाहे तो लिख के रखो. What is the definition of steady state error? Whenever the system response reaches to the final value at very high value of t, that means t tends to infinity. Whenever system response reaches to the final value, at that time whatever is the difference between input and output, that thing is actually called as a steady state error, given by ess of t. Okay, so this ess actually suffix, e बड़ा रहता है उसके नीचे ss bracket में t. ess of t is equal to limit t tends to infinity et. This is the steady state error formula in time domain. What is the steady state error formula in Laplace domain? Limit s tends to 0, s into es. Okay, so whatever s and t, so s is a frequency and t is a time. And what is the relationship between frequency and time? 1 upon. Okay, so s is equal to 1 by t. When t is equal to infinity, s is equal to 1 by infinity is 0. So this is very easily understandable that from es, if you know what is es, if you know what is error in Laplace domain, multiply s with that. What is the formula for es, Vinay? Just now you have proved what is the formula for es.
R of S by 1 plus G of S H of S.
Rs divided by 1 plus GSHS. Multiply S with that. That means S into Rs divided by 1 plus GSHS. And take limit S tends to 0. Okay, so what is the formula of steady state error? That is limit S tends to 0, S into Rs divided by 1 plus GSHS. That is if all the signals are given in Laplace domain. If all the signals are given in time domain, or if you are able to calculate the inverse Laplace transform of ES, you know what is ET, then what is the formula? Limit t tends to infinity ET. So generally बच्चे लोग mistake किधर करता है? What is the time domain formula? Limit t tends to infinity ET. What is the relationship between t and s? They are inversely proportional because s is frequency and t is time. Okay, t is equal to 1 by s. We know that. So limit t tends to infinity et, झट से वो लोग लिख देता है limit s tends to 0 es. But what you miss is one s is there. Okay, so what is the steady state error formula in Laplace domain? That is limit s tends to 0, s into es. वो s एक extra आता है. All these proofs are not there. Have you done this proof anywhere? Do you know what is it called? This is called as a final value theorem. Okay, so actually you are finding the final value of the term et. Final value means at t tends to infinity. Okay, you are finding actually the final value of time domain parameter et, but you are finding that not by inverse Laplace transform. So you are not doing inverse Laplace transform. You are not finding et. Actually you are trying to find out the amplitude of et at t tends to infinity, but that you are able to find out from es itself. तो इनवर्स लैपलेस का एक स्टेप हमारा कम हो रहा है. We won't have to find out what is et. We know es, just multiply s with that. Limit s tends to 0, ses is equal to et at t tends to infinity. Have you heard of this final value theorem in Laplace transform?
Yes, sir.
ठीक है, बट उसका सिग्निफिकेंस तुम्हें पता नहीं था. सिग्निफिकेंस ये है, if I know what is es, if I know what is the function in Laplace domain, and we are actually asked to find out the amplitude of that thing in time domain for very high time t tends to infinity. So what is the step? Es is given to me. Es error है या क्या है वो सोचो मत. Es is just a function, and you are asked to find out that first do its inverse Laplace transform, get et, and then tell me what is the steady state value. that is t tends to infinity. And as this is error, we call it steady state error. But what does final value theorem say? That you don't have to do that inverse Laplace transform. You know Es, multiply S with that, limit S tends to 0. You are finding ESST. ESST is nothing but limit t tends to infinity Et. So एक step बच रहा है. That is the significance of final value theorem. What is that step called? How to find Et from Es. Sometimes Es becomes very complex. Okay, generally we ask small value, small Es and all in the exam, but generally not necessary every time Es will become very small. Sometimes Es can be very big, and in that case finding inverse Laplace transform, that is Et from Es, that becomes a very tricky job. Okay, so you don't need to find that, just multiply S with Es and take limit S tends to 0. You can find what is limit t tends to infinity. So this is actually the numerical, and above also you have found out what is Es. You have found out actually what is Es. You are finding Es is equal to 1 by 3s plus 2 by 3 into s plus 3. Multiply S with this and then substitute t tends to 0. If you are multiplying S with this, what are you getting? Can you tell me? Multiply S with Es. What do I get? What is the equation of S into Es? Just multiply S with this. What do you get? 1 by 3 plus 2s by
1 by 3 plus 2s by 3 into s plus
correct.
3.
करेक्ट एंड उसमें अभी s is equal to 0 सब्स्टिट्यूट करो. व्हाट आर यू गोइंग टू गेट? ये
1 by 3.
सेकंड टर्म क्या है? 2s divided by 3 into s plus 3. As
Only
soon
1
as
by 3
2s is
only.
there and if you are substituting s is equal to 0, this part will become 0.
Yes,
And
sir.
what is the initial part? Initial part is 1 by 3. So what is limit s tends to 0 SES? That is nothing but steady state error. And how much is that value? 1 by 3. Understandable?
Yes, sir.
So SES, that is the one step you have to do. SES जैसे ही कर रहे हो, you are finding 1 by 3 plus 2s by 3 into s plus 3 and then substitute s tends to 0. If you are doing that, only the 1 by 3 will remain. And what is that 1 by 3 called? 1 by 3 is called as the steady state error. That means whatever system is given, what system is given? The system is given as forward path gain is equal to 1 by s plus 1. Feedback gain is equal to 1. Closed loop system I am not talking about. Okay, forward path gain and feedback gain. From there we are estimating if we are finding a closed loop system and if its response is there. Response is nothing but CT. CT हम लोगों ने find नहीं किया. We are trying to find out if there is a open loop system. From there, if we are finding a closed loop system, and that closed loop system is given with an input of Rs. What is Rs? 1 by S. In that case, whatever is the output of closed loop system will be, how much will be its steady state error? That is Ct at t tends to infinity. That is actually output at steady state. And input minus output at steady state is nothing but the steady state error. So from very simple thing, we are actually finding a very complex definition. So this part is not explained in lecture, so this is not for you. So another example we can check, and this is another example, that is RC circuit, and this is the thing. So I think I have shown this thing to you during our initial RC circuit transfer function finding and RC circuit step response. So what is the transfer function of a RC circuit? I think we have done it. So transfer function was 1 by s into RCS plus 1. After that, this is actually was CS by RS. So what is CS by RS? CS by RS is nothing but the transfer function, closed loop transfer function. This was 1 by RCS plus 1. That is V output by V input. Now take RC to the other side. So that means CS become RS divided by 1 plus RCS. Now RS I am giving input as a step input. So this RS actually I am writing as 1 by S into RCS plus 1. समझ में आ रहा है विनय?
Yes, sir.
Okay, so this is 1 by S into RCS plus 1. What is this? This is response, CS. You are finding response. Okay, and what is meant by steady state error? Input minus CS. Input is 1 because input I am giving as steady state. So CS is 1 by S minus 1 by S plus 1 by RC. That means 1 minus e raised to minus t by RC. So output, that is CT, is equal to 1 minus e raised to minus t by RC. So what will be the error? ESST. 1 minus e raised to minus t by rc, because I know that error is nothing but input minus response. So what will be the error? Error is nothing but e raised to minus t by rc. Is it understandable? E raised to minus t by rc will be a falling curve. Okay, so this is ct. This is ct what I'm showing. Is it understandable? 1 minus e raised to minus t by rc. This is a rising waveform. This is output. And you are finding that at very high value of t, okay, e raised to minus t by rc will become equal to 0. And that means what is the output? Output is nothing but reaching to the input. How fast it reaches to the output, output reaches to the input, that depends on the value of rc. If r value is very small, in that case the waveform will reach to the output, or final value of the output, that is 1, very fast. Okay, so rc value we can change, so rc is called as a time constant. So here we are finding that output is reaching or touching the input at a certain time. So how much is the steady state error? Steady state error is equal to 0 in the top diagram. But in the bottom diagram, you see, in the bottom diagram, you see that suppose input given as 1 and output is not reaching to 1. Proof wise, it will reach. Okay, mathematically, model wise, it will reach because there's a capacitor, it's a pure capacitor. But there might be some defect in the capacitor, which is not considered in the model. Okay, which is not considered in the equation. Okay, in that case, we are finding that output is not reaching to 1 volt finally, even at steady state. Output might reach at 0.8 or zero point 0.9 and stay there. Okay, it is possible. In that case, how much is the steady state error? So input is 1 and output is getting steady at 0.8. So how much is the steady state error? 1 minus 0.8, that is equal to zero point 0.2. So this is, top one is the diagram with zero steady state error. That means output touches the input, and bottom is steady state error existing. That means output is not able to touch the input at the t tends to infinity. So in this case, so 1 by 3, whatever was there in the previous numerical, that is output was reaching to 0.67. You have calculated. Okay, input is 1, but output was reaching to 0.67. So this is how you are supposed to draw the steady state error if this theory is asked. So in this case, what we are finding is 1 minus 0.67, this error is 0.33. So steady state error is an important parameter as it helps to find out the system performance accuracy at steady state. So what is meant by steady state? T is equal to infinity. What is meant by transient? T is very small, T is equal to 0. Okay, so this is a concept of steady state error. Any doubt in this?
No, sir.
Okay. Now I will go and explain another very important concept, which is called as the concept of type and order. So with this concept of type and order, I think we'll end our session. So we have only used almost half an hour of our time. Another half an hour is remaining. So let me launch another document, and all these documents I will be uploading today itself. Yes, so I think my document is visible to you. And this is actually the concept of type and order. So type and order, to understand that, first you have to understand what is meant by open loop transfer function and what is meant by closed loop transfer function. Can you define what is open loop transfer function? Or how to
So
find open loop transfer function? Yes, please.
GS into HFS.
Very good. What is GS?
So forward path gain,
And what is HS?
feedback gain.
Correct. So you have understood it. So in this case, what we are going to study is, because today I think we will not be able to finish this topic, that is steady state error. So with this actually, but this fundamental is very much required to understand what is meant by steady state error and how to calculate that. That is, what is the type of the system. Generally in the exam, what we ask is type 0, type 1 and type 2. Okay, these three systems, and there are three systems: type 0 system, type 1 system and type 2 system. तो ये लिख के रखो. And second thing is, there are three inputs. One is called as a unit step input, one is called as a ramp input, and another is called as a parabolic input. So total कितना cases हो गया? So first is type 0 system with all these three inputs. Then is type 1 system with all these three inputs. and type 2 system with all these three inputs. So 9 error you have to estimate. Difficult nahi hai, it's very easy actually. I'm kind of scaring you, but it is very easy actually. Okay, and everybody understands it. So before we are going for error analysis, let us understand what is meant by type. So E 3 into 3. So this 9 cases we can ask in the exam. Any of the one case or two cases we can ask in the exam. That is, find out what is the steady state error of type 2 system with a ramp input. Possible, you have to find out. Or find out what is the type 1 system and its unit step input. How much will be the system error? ये क्वेश्चन समझ में आया?
Yes, sir.
Okay, so three systems, type 0, type 1, type 2. What are the systems? And three inputs. For every input, for every type, you have to estimate how much is the error. So finally, ये एक lab का experiment है हमारा. Finally, we form a table. The type 0 system, step input, ramp input, parabolic input. Type 1 system, step input, ramp input, parabolic. And type 2 system, step, ramp, parabolic. Type 3, type 4, type 5 भी है. कोई problem नहीं है. But only out of this 9, 1 or 2 cases we ask. Check this theory. So this is a, I think 4 or 5 page written material. So I have typed it and बहुत सोच के बनाया है. I think this is going to help you students. So two things you have to remember, and already you know it. What is meant by OLTF? OLTF is nothing but GS into HS. That is forward path into feedback path gain. And open loop transfer function का type होता है. If I am giving you a closed loop transfer function, उसका जो denominator है, that gives you the order of the system. If I am asking you to find out CS by RS, that is GS by 1 plus GSHS, in that case, whatever is the denominator equation, what is the denominator equation? 1 plus GSHS. 1 plus GSHS में जो S का highest power है, that is actually called as order of the system. What is meant by type of the system? So just find GS into HS. So there's a numerical, I think it is possible visible to you. GS is equal to 1 by S, okay, and feedback gain H is equal to 1. So what is OLTF? GS into HS. Okay, in this case, GS into H is equal to 1 by S into 1, that is 1 by S. What is the type of the system? Can you tell me? 1 by S. What is the type of the system? Type of the system is 1. ये कहां से आ गया? ये कैसे समझेगा? Just multiply GS and HS, and numerator नहीं देखना है, denominator देखना है, and you have to see how much, how many S are there. Separate S plus 1, S plus 2, S plus 3 नहीं, only separate S. Okay, so whenever you are finding GSHS, you have to see how many S are there, एकदम separate S in the denominator. Number of S in GSHS denominator is called as a type of the system. Can you repeat what I have told? Number of S in the GSHS denominator is equal to the type of the system. How many S are there in this case? GSHS के denominator में how many S are there, or what is the power of S?
1.
S is equal to 1. So what is this system? This is a type 1 system. Is it understandable?
Yes, sir.
Okay, I'll give you another example. Example 2. What is GS? GS equal to 1 by S plus 1. Previous case, GS was equal to 1 by S. Okay, what is the location of 1 by S? 1 by S, S is there at origin. So denominator is equal to 0, S is equal to 0. Where is the S? What is the root? S is equal to 0. That means the pole is there. Pole of open loop transfer function. Pole means where the denominator root stays. Okay. So GSHS banao and uska denominator is S, that equal to 0. So where is that S? Origin में एक pole है. Okay. In that case, the type of the system is 1. In this case, I am giving you GS equal to 1 by S plus 1 and HS equal to 1. If you are finding GSHS, what is that? 1 by S plus 1. If you are doing S plus 1 is equal to 0, what is the value of S? In this case, second case, S plus 1 is equal to 0. Where is the S situated? Is it situated at origin or S is equal to minus 1?
Origin, sir.
कहाँ से origin में आ गया भाई? 1 by S plus 1. Just make S plus 1 is equal to 0. Whatever is the denominator is equal to 0.
S
So
equal
where
to
is the
minus
S situated?
negative part, sir.
Minus 1. Okay. So what is going to be the type of the system? Is there any pole or is there any s at the denominator? खाली s, s plus 1, s plus 2 नहीं. Is there any khali s at the denominator? No. So what is the type of the system written here? What is the type of the system written here?
0.
अभी समझ में आया? Can you just compare this top numerical and first or second numerical? Why the first numerical is having type 1 and why the second numerical is having type 0? अभी समझ में आ रहा है? So I will give you a GS, I'll give you a HS. Just multiply them. Okay, after multiplying, you are finding that GSH is equal to 1 by S. That means there is one pole at origin. Iska pole OLTF, open loop transfer function ka pole at origin. How many are there? One. So what is the type of the system? One. Next case, GS is 1 by S plus 1 and H is equal to 1. Multiply them. GSHS. What is GSHS called? You know, you have told already, it is called as open loop transfer function. Open loop transfer function का denominator में कितना S है? That is actually called as the type of the system. So how many S are there in the denominator of GSHS? 1 by S plus 1. So what is the power of S? S is equal to 0. So S tends to 0. How much is the value of S tends to 0? How much is the value of S tends to 0?
Sir,
Anything tends to 0 is 1.
yes, sir.
Okay, so यहाँ पे कुछ भी नहीं है डिनोमिनेटर में. Is it understandable? Is there a S at the denominator? नहीं है. S plus 1 नहीं चलता है. S plus 1 is situated at -1. I want how many S are there at origin? How many S are there at the origin? एक भी नहीं है. That means 0. Number of S at origin is 0. That's why this system is called as a type 0 system. Next example you just take. Next example you just take. ये देखो. What is the value of GS now? S plus 1 divided by S square into S plus 2. What is the value of HS? HS equal to S. So multiply GS and HS. Now this is S plus 1 divided by S into S plus 2. Okay. How many S are there in the denominator at origin?
Sir, 1.
समझ में आ रहा है अभी?
Yes, sir.
So what is the step of finding type of the system? Can you tell me in your language?
G of S, H of S में एक S तो होना चाहिए, सर.
एक भी ऐसा अगर नहीं है तो what is the type?
0.
समझ में आ रहा है?
Yes, sir.
ये numerical छोड़ो, but just look at this numerical and I'll just change it a little bit. Suppose I multiply GS and HS.
Confused, sir.
नहीं, confuse की बात ही नहीं है ना. तुम सुनो पहले बराबर से, मेरा logic सुनो. Suppose I multiply GS and HS and I'm finding GS and HS, GS multiplied by HS is equal to, अभी सुनो, numerical अच्छे से सुनो, S plus 1 divided by S plus 2. What is the type then? GSH is equal to S plus 1 by S plus 2. What is the type?
So type 1.
By type 0.
Uh,
S plus 2 को नहीं देखना है, S plus 1 नहीं देखना है. मैं क्या बोल रहा हूँ वो सुनो अच्छे से. You are not concentrating today. तुम्हारा थोड़ा आज distraction है. सिर्फ S देखना है, सिर्फ S. S plus 1 भी नहीं, S plus 2 भी नहीं, सिर्फ S देखना है. If I give you S plus 1 by S plus 2, how many S are there in the denominator?
1, sir.
कैसे 1?
Okay, just the term S, no terms.
Only S. Power of
No
S.
terms.
Only,
No S.
no S plus 1, no S plus 2, no S plus 3. Only S. वही तो बोल रहा हूँ, इसलिए ये तीनों न्यूमेरिकल को कंपेयर करो. फर्स्ट न्यूमेरिकल, व्हाट इज GSHS? Is in
1 by
front of you. First numerical, 1 by S. What is the type?
1, sir.
समझ में आया? Second numerical, what is GSHS?
1 by S plus 1. Type
1 by
0.
S plus 1. तो कितना S है डिनोमिनेटर में? खाली S.
0, 0.
समझ में आ रहा है?
Yes, sir. Yes,
So
sir.
that means S raised to 0 into S plus 1. Because S raised to 0 means 1. तो वहां पे कुछ भी नहीं है. There is no separate S. S plus 1, S plus 2 नहीं देखना.
Yes, sir.
अभी
Understood,
समझ
sir.
में आया?
Yes, sir.
ओके, नेक्स्ट न्यूमेरिकल, जीएस में दो एस है,
यस सर ऐसा।
जीएस में दो एस है, बट एचएस इज एस, सो ये वाला एस और ये वाला एस, नीचे वाला एस कैंसिल हो रहा है. सो इफ यू आर जस्ट सेइंग जीएस एचएस, हाउ मेनी सेपरेट एस आर देयर एट द डिनोमिनेटर?
वन वन।
समझ में आ रहा है? सो इट इज रिटन हियर, टाइप 1 सिस्टम एज डिनोमिनेटर हैज पावर ऑफ एस एज 1, मतलब एक ही सेपरेट एस है. That's why this is called as a type 1 system. So these are all open loop system I'm talking about. Now find closed loop system. So GS is given, HS is given. What is the closed loop system transfer function? G divided by 1 plus GH. So if you are doing G divided by 1 plus GH, at that time you are getting S plus 1 divided by S cube plus 3S square plus S. What is the order of the system now?
थ्री
What
सर।
is the order of the system now?
थ्री 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 सर।
Order is 3. What is the characteristic equation of the system? Tell me, what is the characteristic equation of the system?
एस क्यूब प्लस थ्री एस स्क्वायर प्लस एस।
अभी गलती हो गया ना, इक्वेशन बोल रहा हूं. व्हाट इज द कैरेक्टरिस्टिक इक्वेशन ऑफ द सिस्टम? पिछला वाला भूल गए सब. एस क्यूब प्लस थ्री एस स्क्वायर प्लस एस इज इक्वल टू 0. दैट इज द कैरेक्टरिस्टिक इक्वेशन.
यस सर।
ये 1000 बार बोला था. कैरेक्टरिस्टिक इक्वेशन इज डिनोमिनेटर ऑफ cs by rs is equal to 0. Because whenever I am saying equation means what? Equation means there should be a left hand side and there should be a right hand side. So what is the right hand side? Right hand side is equal to 0. Okay, so s cube plus 3s square plus s is equal to 0. That is actually the characteristic equation of the system. Why is it necessary? After finding characteristic equation, we have to see what are the values of s. So in this case, it will be s square plus 3s plus 1 into s. तो एक s is equal to 0. So एक पोल, सिस्टम का एक पोल 0 में है. फैक्टराइज करोगे तो you are going to get 3 poles. First equation, what is the closed loop transfer function? So open loop transfer function GSH is equal to 1 by S, type is equal to 1. अभी कोई डाउट नहीं है, right?
नो सर।
No. Okay, what is the closed loop system? G by 1 plus GH, that is 1 by S into 1 plus 1 by S, that is 1 by S plus 1. What is the characteristic equation?
एस प्लस वन इक्वल टू जीरो।
Where is the pole?
माइनस वन।
Minus 1 नहीं, S is equal to minus 1.
एस इक्वल टू माइनस वन। यस सर।
Correct? Stable system or unstable system?
स्टेबल।
Stable system because pole is lying in the left hand side of the situation. So we started at ये तुम्हारा अभी पूरा understanding complete हुआ. We started at GS, we started at HS. क्या क्या find हो सकता है? First find what is open loop transfer function. What is open loop transfer function? GS into HS. That is 1 by S into 1 is equal to 1 by S. First thing. Second thing, what is the type of the system? GSHS का डिनोमिनेटर में देखो कितना खाली s है. Okay, so there is only s to 1, there is only s. Okay, so this is the type 1 system. Second cheese, what is the third thing? Find what is the closed loop transfer function. So open loop transfer function does not have any physical significance, but with 1 by s, that is the forward path gain. So 1 by s is called as an integrator, s is called as a differentiator. ये सब तुमको पता है. Now 1 by s and 1, okay, they are in forward path and feedback path. Now you prepare a closed loop transfer function. What is a closed loop transfer function? 1 by s plus 1. Stable or unstable? For that we need to know what is the characteristic equation. What is the characteristic equation? S plus 1 is equal to 0. Denominator is equal to 0 is the characteristic equation. What क्या करना क्या है characteristic equation लेके? First thing, you are supposed to find out the roots of the characteristic equation. Okay, what is the order of the system? Order किसका निकालते हो? Open loop transfer function का या closed loop transfer function का?
क्लोज लूप सर।
Very good. Okay, so open loop transfer function gives you type and closed loop transfer function gives you order. ये सब चीज कोई बुक में लिखा नहीं है because these are very simple things, but students get confused with it because things are not clearly written like this in any book. It is understood that people understands it, but they don't understand. तो ये सब बताना पड़ता है. That's why attending lecture is very important. So we get type from the open loop transfer function. We get order from the closed loop transfer function. So closed loop transfer function is g by 1 plus gh. Denominator equal to 0 is called as a characteristic equation. From there we can find out what is the pole position. So for this system, 1 by s plus 1, S plus 1 is equal to 0, S is equal to minus 1. Final thing, system is stable or unstable? System is stable because S is equal to minus 1. Real part of the pole is negative. Then only system is called as a stable system. Is there any imaginary part in the pole of this system?
No, sir.
No, because S is equal to minus 1. So this is a real root, and this is a real root lying on the negative side of S plane and on the real x-axis. Okay, that means there's a sigma axis, negative sigma axis. That's why it's a real negative root. That's why system is stable. Second system, dekh lo. What is the second system? Second system is 1 by S plus 1 and all. And what is the characteristic equation? What is the characteristic equation of the closed loop system?
S plus 2 equal to 0.
Where is the pole?
S equal to minus 2.
Very good. Which system is more stable? Previous one? Which system is closed loop system? Is more stable? Previous one or present one?
The present one, sir.
Why?
More the negative
Very good.
part,
Thank
more the
you. You
stable.
remember this. So more is the negative, deep into the negative real axis, more stable will be the system. So I can ask you that I give you one forward gain of 1 by S and feedback gain of 1, another forward gain of 1 by S plus 1 and feedback gain of 1. Tell me which of the closed loop system produced by these three is going to be more stable. So what your comment will be? If I am preparing a closed loop system with 1 by S plus 1 and 1, for that the closed loop system transfer function will be having its pole deeper into negative real axis, because this is having pole at S is equal to minus 2. Previous system was having pole at minus 1. Both system are stable, but there is coming a concept of relative stability. अभी समझ में आ रहा है? There
Yes,
is
sir.
coming a concept of relative stability. Both the systems are stable as per control system concept, because poles are there in the left hand side of S plane. But which system is more stable? This system, which is having GS equal to 1 by S plus 1, this system is more stable, because for this system, closed loop transfer function is having pole deep into S axis. Comment on this. S cube plus 3S square plus S. कैलसी है तुम्हारे पास?
Yes, sir.
So can you calculate where are the roots? तो एक तो s is equal to 0. Okay, where are the other roots? So s square plus 3s plus 1, इसका दोनों रूट निकालो. S square plus 3s plus 1.
One is minus 0.38,
Another,
minus 0.26, minus 2.61.
I think minus 0.38 and minus 2.61.
Yes, sir.
0.38 into 2.61.
One second, sir. 1 second, sir.
I think it will be giving you some real and imaginary part. No, you are correct. You are correct. Your calculation is correct.
No, sir. It's minus 0.38 and
Correct. Your calculation is
2.
correct. So we are
Okay.
having three poles. Just look, we are having three poles. One is at 0, another is at minus 0.38, another is at minus 2.61.
Yes, sir.
So looking at this closed loop transfer function, can you understand there will be three poles? Why there will be three poles? Because what is the order of the system?
Order of 3. 3, sir.
Order is 3. So one pole is at S is equal to 0, another pole is at minus 0.38, another pole is at minus 2.61. Comment on stability of the system. Minus 0.38 and minus 0.21 stable poles.
Yes, sir.
But वो zero जो है, so pole on j omega axis, that makes the system marginally stable.
Okay.
Pole in the right hand side of the closed loop pole in the right hand side of S plane is unstable. Closed loop pole in the left hand side of S plane is stable. Pole on the j omega axis, that means real part zero है. समझ में आ रहा है? S is equal to 0. That means exactly at origin the pole is. So what is the real part? Real part is 0. What is that pole called? That pole called as marginally stable pole. So marginally stable means on the verge of instability. समझ में आ रहा है? So s plus 1 divided by s cube plus 3s square plus s. What is the stability comment on that? लिख के रखो, system is marginally stable. समझ में आ रहा है?
Yes, sir.
And why marginally stable? Because दो पोल स्टेबल है. मे बी एक सिस्टम में 50 पोल है, 49 पोल्स आर इन द लेफ्ट हैंड साइड, बट एक पोल तुम्हारा राइट हैंड साइड में है. दैट वन सिंगल पोल इन द राइट साइड विल टेक द होल सिस्टम इनटू इंस्टेबिलिटी. और 50 पोल है तुम्हारा, दैट मींस डिनोमिनेटर इक्वेशन इज s to 50. ओके, बट 49 पोल आर एग्जैक्टली इन द लेफ्ट हैंड साइड ऑफ s plane, बट एक पोल तुम्हारा j ओमेगा एक्सिस के ऊपर है. दैट सिस्टम विल बिकम मार्जिनली स्टेबल पोल. मार्जिनली स्टेबल पोल हम लोग डिजाइन नहीं करते. It is like almost like unstable system. So we have to always ensure that all the poles of the system of the closed loop system are lying in the left hand side of S plane. समझ में आ रहा
Yes, sir.
है? Okay. Then go for another example. Example 4. अभी directly I have given you GSHS. अभी समझ में आ रहा है?
Yes, sir.
Just go through the lines below.
Type 0 system, obviously, because there is no S term.
Correct. Okay, so S means there is no open loop pole at origin. Open loop system का जो pole है, so if you are seeing the denominator equation, it is s plus 1 into s minus 3 is equal to 0. So one pole is there at minus 2, another pole is there at 3. There is no pole at
0.
origin. That means the system type is equal to 0. अभी इतना type पढ़ के फायदा क्या है? That we will see on the next day. Example 5, understandable? Why this is a type 2 system?
Yes, sir.
Okay, so because there is a s cube and numerator there is a s. Okay, so that s and s cube actually they get cancel each other, so denominator is actually having s square. So GSHS is having denominator as s square. S square means
Minus
power
2.
of s is equal to 2. That means this is a type 2 system. Last one.
Sir, if g of x into h of x is only given, then that closed loop transfer function, how to calculate, sir, then?
GSHS given, very good question. We will see that if GSHS is given like this, you take it equal to GS, and that then HS you take as 1.
Okay, okay, okay.
ये
Fine, sir.
समझ में आ रहा है?
Yes, sir.
सिर्फ
Yes, sir.
GSHS दिया है. So one numerical we will do like this. ये तुमने बहुत बड़ा चीज पूछ ली, ये बच्चों को स्ट्राइक करता ही नहीं है. Because I suffered a lot because of this. मेरा पढ़ाने में सब गलत हो रहा था. Because suddenly I was taking HS equal to 2, 3, 5, 7. नहीं होता है. पूरा सिस्टम गड़बड़ हो जाता है. So if GSHS is given, you have to take it as GS. And whenever you are doing this kind of steady state analysis of closed loop system, take always HS equal to 1. Negative feedback, positive कुछ भी ले लो. So GSHS is equal to GS. ये तुम assume करो and HS equal to 1 you take it. Understandable?
Yes.
वैसा नहीं देंगे हम. I will give you comparatively good numerical. So अभी देखो next numerical GS is given s into s plus 8, s plus 6 and hs is 3 by s. So if you're just multiplying this GSHS, what is the type of the system? Type of the system is 0. Understandable?
Yes, sir. Yes, sir. No S.
And what is the where is the pole? Where is the closed loop pole?
S is equal to minus 30 by 4, sir.
Minus 30 by 4 is minus 7.5. Okay, so stable pole, unstable pole.
Stable pole.
It is stable pole. Okay, so this document I will upload. And last example, GS is 1 by s and hs is 2s divided by s plus 5. So if you multiply, it will become 2 by s plus 5. So it's a type 0 system. So I think now तुम्हारा type, order, characteristic equation, pole, stability, all these fundamentals are clear,
Yes, sir. Clear. Easy.
right? So we will stop here. You remember these two formulas, that is steady state error is equal to t tends to infinity et. That is first thing. Second formula is steady state error is equal to s tends to 0 s into es. Okay,
Sir,
so if it is time domain, it is t tends to infinity et. If it
could you
is
tell
s
that again?
domain, huh?
Could you repeat that?
वो दिया था ना, लिमिट t tends to infinity et. because
Yes.
ESS suffix t, that is steady state error in time domain, is equal to limit t tends to infinity et. I will upload all this, तुमको मिल जाएगा.
That
And
same thing in Laplace domain is s
s
tends to
into es,
0.
limit s tends to 0, s into es, because t जहां पे infinity है s 0 है, s जहां पे infinity है t 0 है.
Understood,
ठीक है.
sir.
So same thing in Laplace domain is limit s tends to 0, s into es. So it is
Yes.
not only limit s tends to 0 es, बच्चे लोग वो मिस्टेक करते हैं. So एक s आते हैं in time domain. Okay, so that is one set of formula in time domain and frequency domain, Laplace domain. Second is es is equal to rs by 1 plus oltf, that is gshs. Es is equal to rs by 1 plus gshs. And gshs is called as oltf, and g by 1 plus gh is called as cltf. Cltf stands for closed loop transfer function, and oltf stands for gs into hs.
Yes, sir.
इतना ही आज हम लोगों ने देखा है. So tomorrow what we will do is that 9 errors. कौन सा error? Type 0 system, type 1 system, type 2 system. And what are the types of inputs? Step input, ramp input, parabolic input. So type 0 system will step, ramp, parabolic. How much are the errors of the response? Type 1 system and type 2 system with step, ramp and parabolic. What is the output?